So hello everyone, once again we are here solving algorithms and coding mathematical challenges on the internet, and we are here today with problem number 11 from Project Euler.net, and the name of the problem is largest product in a grid. It says here that in the 20 by 20 grid below, 4 numbers along a diagonal line have been marked in red. So we have this grid, 4 numbers are here. The product of these numbers is 26 times 63 times 78 times 14 equal to this big number here, 1.7 million-ish, right? So the problem asks us to answer what is the greatest product of 4 adjacent numbers in the same direction, up, down, left, right, or diagonally in the grid, in the 20 by 20 grid. We have to look by sets of 4 numbers adjacent to each other, right? And up, down, left, right, or diagonally. So I suppose it's horizontally, right? Like diagonally, such as here, also vertically. And since they're talking about up, down, left, or right, I suppose or the diagonal in the opposite side should also count. It's a pretty simple problem of iterating through a matrix of numbers. Let's give it a try. So the first thing I want to do is to copy this entire matrix for our code. And let's start our code here. So I'm going to create a new Python package, problem 11, problem11.py. I'm going to instantiate my matrix initially as a string, right? As a string of just text. And it's just too easy to process this matrix here. I'm going to make some basic string processing to convert this matrix into a list of numbers. I think it's going to be easy this way. So first, let's just make vectors from each row in this matrix. So just split this by the line break. So I'm splitting this matrix by line breaks. So now I have a list of strings, and let's just process this list of strings. So for each row in this matrix, I'm gonna split it by the space, which is this character in between the numbers here. So let's just print it to see what we have. And we have a list of strings, right? This is not a number yet. We're gonna have to deal with numbers. So to do that, I am gonna do another list comprehension here. So for each number in this row, I'm gonna convert this number to an int. And now we should have a matrix of integers with the numbers that we're looking for, right? Let's give it a try. And yes, we have now a list of numbers. And this should be the matrix we're gonna operate on. First part done. Next part then, let's go through what I wanna do here is to go through the matrix in 4 different ways to find all possibilities of adjacent numbers for us to calculate the product for them. There are 4 ways in my view: horizontally, vertically, the main diagonal, let's say like this, the diagonally, and the anti-diagonally, right? I'm gonna do them in each of them separately, so I think it's easy to visualize the problem this way. Let's start from the horizontal. So the horizontal, I'm gonna have to start with the first row all the way to the last row, and column-wise, we start from the first column all the way to the column in the last position minus 4, right? So we get all the way to here, 50, and then we get these last 4 numbers here. If we go beyond than that, we're just gonna get 3 numbers, and then it's not correct, right? So I'm gonna start with stating the size of my matrix, n is equal to 20, so that we know how many rows and how many columns there are. And I'm also gonna create a variable called largest product and instantiate it with some small number, right? Just as initialization for us to get our results. So first, let's make the horizontal check. So we're gonna go for row in matrix, actually for row in range n, so for all the row in there, and for all the columns up to n minus 4, right? That's what we want to do. And then we can calculate the product of this. How can we calculate the product? We're gonna have to get the 4 elements that for the four cells that were in this matrix and multiply them. I intend to use the math library because math library has a function called prod that, given a list of numbers, this library already multiplied this for us, makes things easier. And I'm gonna get this, since it's just 4 numbers, I'm gonna get these numbers manually here. So matrix, we're gonna get in the position that we are right now. Not I and J. Yeah, I like to call I and J, so let's call like this, right? And then since it's horizontally, we're just going to increase the columns. The row will keep the same. So it's going to be this one here, plus 1, and plus 2, and plus 3. So we have the current position, plus 1, plus 2, plus 3. We have the 4 numbers that we need. Given the product, we need to check if it's the largest product, right? So we can just replace largest product by the max of itself or the product, right? This is the horizontal check. We can print the largest product, but this is not the final answer just yet, but just to see if there are no errors in our code, right? Let's just clean here. Let's just run it. Yes, we have a number here, but I don't know if this is the largest number. Again, let's do the other checks. Vertical check. The vertical check is going to be the opposite of the horizontal check. We're going to go through every column from first column all the way to the end, but row-wise, we're just going to go all the way to 20 minus 4, right? All the way here, right? Because if we go further, we're just going to get numbers that are not 4 adjacent numbers. So it's the opposite from this one. So let's just copy the same thing. And it's all the way to n minus 4 rows, but all the columns. And instead of increasing the columns, we're going to increase the rows, right? So this is the opposite of the previous check. That should do it for vertical check. Again, just run it. We have a different result, but I'm not sure if this is the right result because we still have to check diagonally and the anti-diagonally. The diagonal check, we check from the position that we are right now, and we increase the row and the column by 1, by 2, and by 3. And this pass, since we're just checking both ways, the 2 dimensions increasing by 1, 2, and 3, we also have to, we're going to have to check the rows from the first row all the way to n minus 4 row. And the same thing for the columns. So from the first column all the way to n minus 4 column. This is going to be like for I in range all the way to n minus 4. And vertically, similarly, the column wise is also the same. So n minus 4. Let me just copy this code here, makes it easy. And here we're going to have to increase the rows and the columns by 1, by 2, and by 3, both of them, right? So this should be the diagonal check, right? Let's see if there are no errors in our code so far. No, but we also have to check the anti-diagonal check. In the anti-diagonal check, we're going to check from the initial cell. We're going to increase the row by 1, but decrease the column by 1. So plus 1 row, but plus minus 1 column. Same thing here. Plus 2 rows, but plus minus 2 columns, and so on. For that, we have to start from the cell number 4 here, or starting from 0, the cell number 3, 0, 1, 2, 3, all the way to the last column, and row-wise from the first row all the way to n minus 4 row. I'm going to copy this because the code is pretty much similar, but just the rows are different. So rows are the same, but the column, we're going to start from 3 all the way to n. And then we are going to increase the row, but decrease the column. Increase the row, but decrease the column. Increase the row, plus decrease the column. That should do it. Let's see if this gives us the response, the answer to the problem that we're looking for. I suppose that the answer is in the anti-diagonal check. So let's see. Let's paste the answer here and hope for the best. And yes, congratulations, you gave the answer to the problem 11. This is a simple problem. It's just annoying to check all of these little rules in all of the ways. Thank you so much for watching. And if you liked the video, please like, share, subscribe, turn on the notification bell. This helps a lot. Thank you so much, and I see you next time. Peace.